Hey everyone, it's Colin. How's it going? Unfortunately, while I've got a whole ton of projects that I've been working on for future videos, like all of them are being held up while waiting for parts to ship or that are stuck in shipping from overseas. So it's like, what do I do? Well, not all is lost, because this gives me an opportunity to finally fix up this little guy. If you watched a previous episode about the Nomad Jukebox portable MP3 player, go ahead and watch that one if you haven't already. I also talked about this. This is a Sony D-CJ01 portable CD player, but it was also my first MP3 player because it'll play MP3s that have been burned to CDR and RW discs. So I've had this player since about 2001 when it first came out, and I used it for a solid 2-3 years before finally going and buying an iPod, kind of like everyone else. At that point, I put this thing away and pretty much never touched it again. Unfortunately, I accidentally left a pair of batteries inside it, and well, you kind of can guess what happened. I did what I could to clean up the battery compartment, just kind of briefly, but you can still see some residue down in here. The battery contacts are still covered a little bit with some of the leaked electrolyte, but my big concern is, well, what may else have been damaged in the process? Did that electrolyte leak anywhere else inside this player? Now, I have a theory that the problems with this thing are due, at least in part, to a power delivery kind of problem, because I did just a little bit of testing with this off camera and the results are kind of interesting. So what I started with was just a standard pair of rechargeable AA's, just some Eneloops. These are fully charged up, ready to go. And then as a way of seeing what's going on, because the lid on this is clear, I'm just going to throw a disc in here that's got some contrast so we can see what happens. Watch when I close it. All right, so it doesn't do anything off the bat. Then it waits a second and kind of like half-heartedly spins the disc, and then it's like analyzing the disc a little bit, but notice there is nothing on the screen. And if I press play, nothing happens. Basically, it kind of tries to read the disc, but it won't do anything with it. The motor, I can hear the motor for the laser carriage kind of moving back and forth a little bit. That may be a different problem. But the fact that it's not fully spinning the disc up is really interesting, and also that there's nothing on the screen. Now, let's pull the disc out. And I'm going to try swapping batteries. And this is where I started getting some really interesting results. So instead of those, Eneloops, as I proceed to drop everything on the floor, I'm going to throw in a pair of AA disposable batteries. These are lithium batteries, but these will output 1.5 volts, whereas the Eneloops, just like any nickel metal hydride rechargeable, these are only 1.2 volts each. So these have a little bit higher voltage. And this is where it kind of got the gears in my head turning a little bit. See? Stuff on the screen. Now, there's not much on the screen. It's still clearly not working right. But I'll occasionally, as I've tried this, get different kinds of like garbage on the display. And one thing that I would notice sometimes is that the battery indicator would flash with just one segment in it as if like the battery was dead. Let's kind of start to take this apart and see what we can find. Now, this is a Sony product, so it's probably JIS screws instead of Phillips. There is a difference between the two. Long story short, JIS screws look a lot like Phillips screws. Like a lot like Phillips screws, but they're just slightly different. You can kind of get away with using a Phillips driver on them, but there's a higher risk of stripping the heads out. Looks like there are two in the back here. And that's it for exterior screws. One thing that I've always liked about Sony products, other people have noticed this too, is basically whenever you need to take something apart, they'll put like one of these kind of arrows next to the screw holes. So even though Sony's been really good about service manuals, this is just nice stuff for repair and troubleshooting and, you know, ongoing maintenance and that sort of thing. I wish more companies would do that, where they'd even put it right on the product that helps you take it apart. Happiness is a brand new spudger. Let's see if we can pop this apart. It looks like there's a seam around the edge here where the lid is attached to this kind of inner piece, which sits inside this outer plastic, the bottom half of the housing. It's kind of like a bowl shape. I'm not quite sure how the hinge works. I'm hopeful that it's attached to this upper piece and that I don't have to do some weird crap with springs and everything, because that would be no fun. Watch those go flying all over. Start to gently pull this up. Okay, yep. Okay, alright, so it's separated, but yeah, I thought as much. There's the ribbon cable back here that goes to the top because the controls are all up on the top. And unfortunately, it looks like that ribbon cable snakes under here somewhere. Here's the laser assembly, and it just, oh, interesting. It just rests on top there on some rubber mounts for some shock absorption. Of course, this thing has, you know, memory buffer protection in it for anti-skip, but, you know, whatever mechanical mitigation you can do is also going to be helpful. There we go. Okay, so there's those two, and then now just the ribbon cable here. Something I just noticed as I kind of lifted this up a little bit to see what's going on. First off, the ribbon cable is adhered down to the PCB with some like double-sided tape, so I'll have to very carefully peel that up. But look at this. That looks like, see, it scrapes up. That looks like a little spot of battery electrolyte that somehow made it back there. I have no idea how, because this is all pretty well covered from the battery compartment, which we'll look at closer in a second. The battery compartment's all the way at the front of the unit. This is towards the back. How did a spot of battery electrolyte make its way back there? Some of it did get on the ribbon cable, but these are epoxy coated, or at least plastic coated. They're actually surprisingly durable, the flat flex cables. So let's just start to try to pry this up real gentle. I'm just going to use the flat side of the spudger to start, see if that helps me at all. Maybe not. We might have to just do this by hand. Alright, so there was just a little bit of adhesive on that. That actually was just a small spot. And then now we get in here and lift up on the bail. Is this a lift? Let's not have a repeat of the last time I tried to disconnect a flat flex on a Sony device. If you've been watching me for a while, you probably remember the A5100 saga. I think this bail flips up. I'm going to use my fingernail. Yeah, okay. The bail on this connector flips up. But our laser assembly is free now. So here's a better look at the battery compartment. You can see this in this area is where the bulk of the leakage occurred, and that's also where I cleaned up when I first discovered the problem. It all seemed to be on this side of the compartment. The other side is actually very clean. I think it was only one battery, the one in this lower or closer to the front section, that actually did the leaking out the back end of it. This side seemed to be fine. But can you see this little trail of electrolyte leading this way? that exited the battery compartment. And when we get this circuit board out, I really hope I don't find a whole bunch more of this on the back side of this board, you know, leading to the problem. You probably already noticed there are electrolytic caps on this circuit board, some surface mount ones, and you may have already started furiously typing down in the comments about how they're the source of the problem. I'm not immediately suspecting these surface mount caps, primarily because one, they're not bulging, and two, I'm not seeing any signs of electrolyte or residue anywhere on this board. Other than that little spot of battery leakage over in the upper corner by where we disconnected the laser assembly, this board is very, very clean. I'm just not going to suspect these. I mean, could they be on their way out? Yeah, maybe. And we'll troubleshoot them if it looks like that's a possibility, but I just visually, I'm not seeing anything that implicates these. I think the problem lies elsewhere. Oh, yep. Here we go. Yep. Success. Okay, good. And this ribbon cable was not stuck down to the case. Just set that out of the way for now. We'll come back to that in a second. Figure out how to disconnect this cable before I damage everything. I'm not sure what's going to be the best way to try and get this one out, because unfortunately, as you can see, they like folded the cable over. It does like a 180 and then goes into the connector. I'm not sure why they did it that way. Maybe just to give it a little bit of extra, you know, springiness, extra slack as the lid opens and closes. But I'm gonna try, I think, to get the spudger in here between that reinforcing tab and the board, just to give me something to kind of press up against and slide it all out as one piece. Yep. Yep, there we go. Here's a better look at that tab and then the connector that it all goes into. All right, let's take a look at the bottom side of this board while we're at it, just kind of check out some of the components. There really aren't any chips on the top side of the board. Pretty much all the exciting stuff's going on underneath. And this board, this part of the board, remember, faces downwards. Right off the bat, it's actually surprisingly clean. I'm not seeing any sort of electrolyte residue, either from failed caps or from when the battery leaked on this board. So that's a really good sign. Doesn't mean we're out of the woods yet, but it's starting to lead me in a certain direction. Some of these chips I'm not surprised by, and some of the chips I am. This one underneath the label, this is actually, I believe, a Sony chip, and it's kind of the brains of the operation, at least when it comes to dealing with the files on the disk and navigation through folders and understanding the format that a data disk has been formatted as, other than like a standard, you know, Redbook audio CD. This is kind of like the star of the show for all of the MP3 playing capabilities, but it doesn't do all of the work itself. This chip from Winbond is a 128 kilobyte RAM chip. This sounds more like kind of operational memory for a very lightweight real-time operating system kind of thing that this chip may be running. This chip works directly with this chip, and this is an MPEG decoder chip. What's interesting is Sony made this themselves. This is a Sony branded part. By this time in 2001, there were other companies that made dedicated MPEG decoding chips or system-on-a-chip type of platforms that would have combined a bunch of these functions. Yet Sony took it upon themselves to make their own hardware-based MPEG decoder. It made sense for them, considering how big they were and the variety of products they made, to actually spin their own MPEG decoder chip instead of buying it from someone else. This is the chip that I find most surprising and interesting. It's this chip from Toshiba, and Sony has bought chips from Toshiba before. I've seen them in other products that I've taken apart. But this is actually the chip that controls the operations of the laser assembly. So it's what does like the motor control for the laser carriage and controlling the laser itself, powering it, all that kind of stuff. This is kind of an all-in-one, make a CD player work. I'm surprised Sony bought it from Toshiba. Because Sony, I mean, you think portable CD player, and just like you think portable cassette player, a lot of people think Sony as a brand. Like, that's the first thing that comes to mind is Sony Walkman, Sony Discman. Yet Sony went to Toshiba to buy this chip. I would have expected Sony to have had their own silicon to do that, and or integrated that silicon into other chips. But, you know, they apparently didn't find that useful. Maybe they did in other Discman models and just didn't think it would work that well architecturally with this one. Or maybe they never did. I'm not sure. I haven't really torn down many other Sony portable CD players before. If you have, let me know down in the comments what you've found for parts inside. But I just found that really interesting. You know, like the leading provider of portable CD players around the world during its time period, and they used one of the most crucial parts from another manufacturer. Anyway, this is a chip from Okidata, and it's also RAM. I'm guessing it's going to be probably in the like 2 to 4 megabyte range. While using this player, I remember it periodically spinning up the disk to read more information, like when playing MP3s, but it was only every few minutes. It wasn't like every few seconds like it would be if it had a chip as small as 128 kilobytes. I mean, a chip this small, even at relatively low MP3 bit rates, it'd be spinning the disk up every few seconds, really, to read more data. So they'd go with something a bit bigger. And then this chip is kind of like the everything else portable CD player playback chip. So it works with the Toshiba chip. It gets either Redbook, digital audio, or, you know, the MP3 decoded audio into this chip. It's also got the analog to digital converter to get the signal from the laser itself. So it actually does all the decoding of what the laser is seeing on the disk into ones and zeros inside this chip. It also has the digital to analog converter to take the digital audio and output it as an analog signal. And then it does all the laser tracking control, like when you skip ahead and it needs to shuttle the laser assembly a little bit further down the disk. This chip does a lot of that too. So this is kind of more of the hardware level of controlling the laser and the assembly and spinning the disk. And this is, I guess you could say, maybe more of the software level of it, the logic to doing all of that. And this is a Sony chip, so I'm not surprised by this at all. And then this chip feeds this chip, which is basically just the headphone amp. So they do have an outboard headphone amplifier, which makes sense given the side of the board that it's on, because the headphone jack and line level jack, see, they're just on the opposite side of the board here. So they're close by where that is. I'm not seeing any sort of weirdness with solder joints. It is kind of weird the way they did some of these. It looks like the through hole components, basically the DC input jack over here, the line output, the headphone jack, and then maybe even the battery contacts and some of that stuff. It looks like those may have been hand soldered. I'm seeing some flux residue on the boards, and these joints aren't very consistent like they would be if it was a machine that did them. That said, I mean, they're not poor solder joints. They just look kind of handmade. I know no one has been in this player before because I have owned it the entire time and I have never taken it apart. And it was also a brand new player. It wasn't like a refurbished one or anything like that. So unless there was some kind of weird factory rework that happened before it left the factory the first time, this is just the way they came out, which is rather interesting. Yeah, so here's the inside of the bottom housing. And as I suspected, the electrolyte definitely leaked, you know, outside of the battery compartment, but it actually didn't really get all that far. So I think I'm just going to go through with some IPA, try to clean all this up as best I can. I'll peel this guy out, but I won't throw it away in case for some reason it is necessary. And then just kind of work my way back and do a bit more scrubbing in the battery compartment. One thing that's really interesting is, so I scrubbed this up pretty good. I've gotten pretty much all the residue gone, yet you can still see like there's these discolored spots in here. I think that's actually where the electrolyte from the battery has eaten away at the paint. This is just a plastic bottom panel, right? Same thing with the top. The whole player is basically just plastic, but it's this silver painted plastic. Same on, the bottom as well. I think this kind of what looks like beige part is actually the original color of the plastic before it got painted, and the electrolyte ate through the paint. So this is about as clean as I'm going to be able to get it. I think there's really nothing left in here that could possibly touch electronics or whatever. So I'm pretty sure we've done all we can with this bottom housing. So with all those plastic pieces cleaned up, I'm just coming back to this board, and specifically, I kind of suspect maybe these battery terminals are at least part of the problem. It just feels like there's a coating of something on here. Like that electrolyte somehow bonded to the metal or something, and I wonder if it isn't as electrically conductive as it needs to be. I wonder if it's like partially electrically conductive, but if it's just, I don't know. Let me try to clean that off. Let's see what we can do. That cleaned it up quite a bit. You can see how much shinier and nicer it is down here where I sanded it. Trying the 220 didn't really add a whole lot of kind of polish or, try to bring the chrome super shiny kind of finish back, but at least it's down to bare metal and all of that corrosion and stuff is gone from where the battery makes contact. So I don't know. Let's see what that did. I think I'm just going to try putting it back together and see what that does. Okay, so I haven't bothered to put the screws back in yet, although I don't think that's going to matter for testing purposes here. It all fits correctly. Let's throw some batteries in here, and I'm going to try with the lithium AA's, the 1.5 volt batteries again. I'd be surprised if this thing wasn't able to work on nickel metal hydride rechargeables. I didn't have any back when I originally bought this, so I can't say for sure, but let's see at least if it tries to do the same thing as before. Oh, that's, I think, a way better result than before. It seemed like the disc was spinning faster. I also heard the motor for the carriage pull the carriage back in the middle. I intentionally pushed it out of the way just to see if that would make a difference. Let's press play and see what happens. I think it's playing. I don't see anything on the screen, but that may be my fault in trying to get the ribbon cable back into the motherboard. It was a fiddly connection. I'm going to try and go back in there again and see if I can reseat it properly, but it's playing now. Let me check the screen. Let's see. Let's see if we can get this working for good. Okay, back to peeling the onion here. Reseating the cable didn't help. I got the screws taken out that hold the outer control panel to the clear acrylic lid. And yep, now it just kind of unsnaps, and there's this plastic sheet, I think just for appearance sake. Yeah, because otherwise you'd see the bottom of the PCB. And, well, my thought was that maybe the other side of this flat flex had gotten loose or dislodged or something, but that's not the case because it appears, yeah, it's permanently connected to this PCB. I mean, looking at this flex closer, it's in good condition. There's no obvious broken traces along it, no super sharp creases or anything that could really, you know, impact its ability to function. The pins on the end are nice and clean, and I went over them with some IPA just to be sure. I guess it, you know, this board is kind of interesting in a way in that it's just super thin. Look at how thin that PCB is. It doesn't really have a whole lot going on. I'm pretty sure this is called chip on board. It's basically where they take the die of a chip, but they don't encapsulate it in plastic like you would normally see on a, you know, on a chip. But then they solder it directly to the board and then blob a little bit of epoxy on top. Not only is this cheaper to do, but it's also like less space that it takes up. It can be a lot thinner, a lot more compact. Some companies will actually do this intentionally as a way of preventing like industrial espionage, where other companies can reverse engineer their products and that sort of thing, because this epoxy is really difficult to remove without damaging the chip underneath. So I think in this case, you know, this is just a display controller driver. Maybe it does some sort of multiplexing with the buttons as well, just because there's only so many wires in this flat flex. There is the possibility that the problem is with the display. That'd be super weird because it just worked kind of at the start of this whole episode. I don't want to call it anything else just yet because we're not 100% sure whether we're victorious or a complete fail. But anyway, I'm not really suspecting this board as being part of the problem. Let me just try and put this whole thing together again and see if I can get the display to work correctly. So try as I might, the display still doesn't work. Obviously the player is still playing and you can like skip through tracks and it'll do all that. That's no problem. But this display is now completely dead. And I just don't know why. I reseated the flat flex into the motherboard a few times. I'm confident that it's in there well. And then I took the PCB for the display out while leaving that flat flex connected and hit it up with the multimeter for continuity between the connector on the motherboard and the connector on the display PCB. All of the pins checked out for continuity. So I know the connection and the flat flex between the display and the main board, they're good. I did a little bit of research online. I found that there's not a whole lot of information about this particular model out there, but I did see a few reports from other owners saying that they had problems with their displays failing as well. Maybe these displays are just very sensitive. Maybe they're prone to failure. Who knows? Maybe the solder joint between the display panel itself and that really thin PCB was very weak to begin with. And just the act of taking the unit apart was enough to slightly flex it and crack those joints. I'm not sure. Either way, I'm about as far as I'm willing to go this time around. What I think is going to be the best path forward, if I decide to really get this thing up and running again, is to find a parts unit and just swap over components. This model actually isn't terribly expensive to find a used one. Obviously, prices on used portable audio are continuing to go up because they're becoming kind of a trendy thing. Like the prices for cassette, like old school 80s Walkman players, is just nuts. I might pick up a spare, or I might just say, you know what, this is a showpiece only and it's non-functional, at least when it comes to the display, and just kind of leave it as is. I'll throw the screws back in it, button it up, and just call it a partial win. I am surprised that all it really took to get this thing functional again was cleaning those battery contacts. I was expecting it to be way more involved, but of course I'm disappointed that, well, the display decided to break in the process. That could be my fault, it could be its own fault. Either way, it is what it is. So if you like this one, I would appreciate a thumbs up. Be sure to subscribe. You can follow me on Twitter and Instagram at thisdoesnotcomp. And as always, thanks for watching.